Hello, my dear students. I'm Shuman from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, in this video, we are going to study your ICSE Class 9, Chapter number 4, Atomic Structure and Chemical Bonding. And we are going to continue studying the concepts of this chapter because we have already studied about the atomic structure in very much detail in the previous video. So if you have missed that video, you can go back, you can search for that video and you can study and understand the concepts and then move to this video, because many of the basic concepts of the structure of atom you can understand, and that would help you understand the chemical bonding part, which we are going to start from this video. Okay, so here we are going to see about the ionic bonding. Okay, we are going to understand ionic bonding and we are going to see how ionic compounds are formed by looking at the atomic, by studying how to draw the atomic orbit structures of the compounds. Okay, so also, we are also going to see some questions at the end of this video so that you would get a fair understanding how much you have understood. So without wasting much time, let's start and let's rock. Okay, so let's first simply go through the topics which we are going to study in this video, which is first we are going to see what is actually a chemical bond. Then what is ionic bond, what are ionic compounds, which is very essential to which you should know first, and then we would jump on to how the ionic compounds are formed by exactly learning to draw the atomic orbit structures of these three compounds, NaCl, MgCl2 and CaO, sodium chloride, magnesium chloride and calcium oxide. Okay, so what is a chemical bond then? Very simple. Okay, suppose you and your best friend, okay, you are walking on a road. So there is a natural, okay, affection between you two. So you can take your, take your hands together, okay, while walking. You can hold your hands together, while you are walking, or you can just put hand on the shoulder of your best friend. Okay, so that affection, okay, if it is present between the constituents like atoms or ions, okay, so that affection is simply called as the chemical bond, nothing else. Okay, so in chemical species, okay, between the atoms or ions, if that force of attraction, if that affection is present, that affection we call it as chemical bond. So chemical bond is simply the force of attraction between the constituents, okay, in the different chemical species. Okay, so see, force of attraction, right? Okay, the force, the affection wala behavior. Okay, so attractive force present between the constituents of the chemical species. Okay, so this attractive force, okay, is holding the constituents of different species. Okay, so how you and your friend are being held, okay, by holding the hands. So in that manner, this attractive force, okay, which holds various constituents, different constituents like atoms, the constituents can be ions. Okay, I will tell you by giving an example, okay, which are present in the different chemical species. Okay, so chemical bond is simply the attractive force which is holding the various constituents like atoms or ions, okay, together in different chemical species. For example, I am talking about sodium chloride. So here we are going to study about this. So in the sodium chloride, there the constituents are sodium ions and chloride ions. So what are these ions we are going to see? Okay, but for now you just focus on this names, ions. Okay, so this is having positive charge, this is having negative charge. In our sodium chloride, it is made up of these positively charged ions and negatively charged ions. Now the attractive force which is holding these ions, together, okay, in this chemical species is the chemical bond. Okay, fine. For example, let's see another example. Suppose I am talking about, okay, this hydrogen molecule. Okay, so now in this hydrogen molecule, okay, let's not put this dash here. Suppose I'm talking about hydrogen molecule. So here this is one hydrogen atom, this is another hydrogen atom simply. Okay, don't focus on these details right now. So these two hydrogen atoms are being held together by an attractive force. Okay, so the attractive force which is holding the atoms, together in this chemical species, which is hydrogen molecule. So this attractive force is called as chemical bond. Now, in both these cases, the attractive forces are different. That's why we can say that chemical bond, okay, are of two types. Here the attractive force, okay, which is present between the sodium and the chloride ions is a chemical bond, but that chemical bond's name is ionic bond. Okay, so the attractive force between sodium ions and chloride ions, we can say that it is an ionic bond. Okay, or we can say ionic bond is present between these ions, and the attractive force between these hydrogen atoms, okay, it is a chemical bond, but it is which type of chemical bond? Covalent bond. Okay, so I have just tried to introduce two types of chemical bonds to you, ionic bond and covalent bond. Don't worry, we are going to study each type of bond in very much detail. So in this video, we are going to study about the ionic bond. So what is ionic bond? What are ionic compounds? How they are formed? Okay, so now let's see what is ionic bond. Okay, very simple. It is a chemical bond which is formed. You need to understand this thing. Formed due to transfer of electrons from the atom of an element to the atom of another element. Okay, so whenever a chemical bond is formed due to, suppose this is an element X, this is an element Y. Okay, this is the atom of element X. Okay, this is the atom of element Y. Okay, so whenever a chemical bond is formed due to transfer of electrons from the atom of one element to the atom of another element, suppose this X is giving up an electron. Okay, so it is losing the electron, and this Y is gaining that only electron. Okay, Y is gaining this electron. So what is happening here? There is a transfer of electron. So whenever a chemical bond is formed due to the transfer of electrons from the atom of one element to the atom of another element, that is called as an ionic bond. Okay, chemical bond is formed due to the transfer of electrons from atom of an element to the atom of another element, okay, is ionic bond. Clear? Okay, now what are ionic compounds then? The definition would exactly be the same. These are the chemical compounds which are formed due to the transfer of electrons from the atom of an element to the atom of another element. Simple. See, chemical compounds formed due to the transfer of electrons from the atom of an element to the atom of another element. Okay, so whenever the chemical compound is formed in this way, that chemical compound is called as ionic compound. Clear? Okay, so friends, now let's see how the ionic bond is formed, how an ionic compound is formed. Okay, so we are actually going to see how the NaCl is going to form. Okay, and when we are going to see its formation, so at that time we are also going to see the atomic orbit structure of NaCl as well. Okay, simultaneously. So it's very simple to draw this atomic orbit structure. If anyone asks you to draw the atomic orbit structure for the formation of NaCl, so you can just simply start with, first you have to start with the elements from which that particular compound is formed. So here sodium and chlorine, these are the two elements. So first we will draw the sodium atom and chlorine atom. Okay, and how we are going to draw? A very simple technique. In the center we are going to show the nucleus. Now instead of writing normally just N as nucleus, you just write the name of that atom. Okay, so if you are drawing a sodium atom, so just write on the nucleus as Na. Okay, so that would help us to distinguish which atom we are drawing, right? Then simply this is the nucleus of sodium. Then now we have to draw the shells. So before that, for that we need to know the electronic configuration. Now I have already explained you how to get the electronic configuration. Okay, we have studied the rules as well in the previous video, so that's why I have told you to watch that, because you would get the basics of the bonding as well. Okay, so here now I'm not going to derive the electronic configuration again and again, because it's very easy. With practice you could also quickly get to the electronic configuration in just few seconds. Okay, so I will just simply write the electronic configuration. If you want, you can pause the video right away. You can think on your own about the electronic configuration of sodium. Okay, and you can write the electronic configuration of sodium based on your previous knowledge. Okay, based on the rules which we have studied. So sodium's electronic configuration is simply 2, 8, 1. So this means that there are 3 shells which we need to show for sodium, right? First shell, second shell, third shell. The electrons, the shells in which electrons are filled, we can observe, we can see from the electronic configuration. So only those shells we need to draw. Okay, so here only 3 shells needed to be drawn, because in only 3 shells the electrons are being filled. So this is the first shell, this is the second shell. Okay, and yes, I will just erase it and write it slightly downwards. Okay, this is the third shell. Okay, here I will write the electronic configuration 2, 8, 1 for sodium. Okay, so now here the electrons, okay, you need to show here in this orbit, atomic orbit structure. Okay, so for sodium, now this is the nucleus. Okay, don't get confused. This central is nucleus part. Okay, now here I know 2 electrons in first, 8 electrons in second, and 1 electron in the third shell. So I'm going to just show in this way only. So I can use cross, I can use dot, so anything I can use. Okay, so I'm using dots. Okay, for example, see, or I'm using crosses. Okay, see, 1 cross, 2 cross, here 2 electrons, and then 8 electrons in the second one. So 3, 4, 5, 6, 7, 8. Okay, and what I will do is I can just change the color so that it is more visible to you. The electrons are more visible to you, right? See, 3, 4, 5, 6, 7, 8. 8 in the second one, and in the last shell, the third shell, there is only 1 electron. So this is all about the sodium atom. Now moving to the chlorine atom. So in the same manner, see, I will just draw the chlorine atom's nucleus first. Then we need to know the electronic configuration to draw the number of shells. So chlorine's electronic configuration is 2, 8, 7. Okay, now here same way you can also derive the electronic configuration based on the rules. So if you want, you can just pause the video. Okay, before I write the electronic configuration, think on your own, try to apply the concepts which we have studied in the previous video, and then you can write simply the electronic configuration. Okay, so chlorine is 2, 8, 7. Then there are 3 shells which needed to be drawn. So 1, 2, and then the third shell. Fine. Then I'm going to show the electrons in it. Okay, so for electrons I'm going to use some different color. So here I'm going to show the electrons by dots, suppose, or by circles. Okay, so see, this 2 electrons in the first shell, then again same 8 electrons in the second shell. So 4, 5, 6, 7, 8, and then 7 electrons in the third shell. So 1, 2, 3, 4, 5, 6, 7. Right? So this is all about the sodium atom. This is all about the chlorine atom in the orbit structure diagram initially. So from this, what the story here is, try to understand this in the form of story. Okay, here the sodium atom and here the chlorine atom, they want to become stable. Okay, so the last thing which we studied in the previous video was atoms tend to become stable. Okay, everything needs stability, atoms also need stability. How they attain the stability? By attaining the octet in their outermost shell, or by somehow getting 8 electrons in their outermost shell. Okay, so now in this case, here sodium, okay, here it is having 1 electron in its outermost shell. Okay, but if it wants 8 electron in its outermost shell, what it can do is it can just give up this 1 electron which is there in its outermost shell, so that its inner shell becomes the outermost shell, which already has 8 electrons. Okay, and in this race of attaining 8 electrons in the outermost shell, what actually our atoms do is, when they attain 8 electrons in their outermost shell, they actually indirectly attain the noble gas configuration, the noble gas configuration of the nearest noble gas. Okay, or I can simply say they attain the nearest noble gas configuration. Now what is this nearest noble gas configuration? You can just figure out from the words itself. Okay, noble gas, we all know, inert gases, helium, neon, argon, krypton, xenon, radon. These are the noble gases. So helium, neon, argon, krypton, xenon, radon. Okay, by attaining 8 electrons in their outermost shell, atoms actually what they do? They attain the nearest noble gas configuration, which means the configuration of the nearest noble gas. Okay, so for sodium, the nearest noble gas is neon. Okay, because see, sodium's atomic number is 11, right? Sodium is 11, neon is 10. So nearest noble gas is 10, and the next coming noble gas is argon, right? But argon is 18, so it is farther than the neon. So nearest noble gas is neon. By attaining 8 electrons in its outermost shell, sodium is actually attaining the configuration of neon. How? See, if it loses this 1 electron, its configuration would become 2, 8. Correct? And if I talk about the configuration, electronic configuration of neon, it is having 10 electrons. So first 2 electrons in the first shell, remaining 8 electrons in the second shell. So this is actually the configuration of neon. So what is happening? See, when the sodium is doing something because of which its outermost shell is getting 8 electrons, it is actually attaining the nearest noble gas configuration. Clear with this point? So here sodium also does the same thing. It tends to lose its 1 electron. But now the story doesn't end up here, okay? Because just sodium doesn't end up losing 1 electron. That same electron, okay, has something to do with the chlorine atom. How? See, let's see. For chlorine atom also, the same story applies. It also wants to become stable. For that, it also wants 8 electrons in its outermost shell, so that indirectly it gains the nearest noble gas configuration. Okay, the noble gas configuration which is the noble gas configuration which is nearest to the chlorine. So for chlorine, see, chlorine's atomic number is 17. So for chlorine, the nearest noble gas is argon. Okay, the next one is krypton, but it is too far away. Okay, so here what chlorine does, it is just short of 1 electron, right, from the nearest noble gas configuration. How? See, the argon's electronic configuration is, see, since its atomic number is 18, if we could figure out the electronic configuration, it is simply 2, 8, 8. Okay, now see, it is just short of 1 electron from the nearest noble gas configuration, right? Just short of 1 electron. If the chlorine gets 1 electron here, it also becomes 2, 8, 8. Understood? So the electron which is lost by the sodium here, this fellow, this is being accepted by the chlorine atom. Okay, so sodium atom loses that electron, chlorine atom gains that very electron, that only electron, and here happens the transfer of electron, the losing of electron, the gaining of electron. Understood? Now, when sodium atom loses electron, okay, we will see about the transfer further, but when sodium atom loses the electron, what happens is, it is short of 1 electron now. Okay, now its nucleus, okay, see, initially it is having 11 electrons. Okay, so this means that it is a neutral atom first of all, and initially it is having 11 electrons. This means it is having 11 protons, but now 1 electron is lost. So 11 protons are still there, but 1 electron is lost. Therefore, out of 11 electrons, now 1 is lost. So 10 electrons are remaining then, right? Sorry, here 11 electrons are there. Okay, but after losing 1 electron, 11 protons are there, but now 10 electrons are remaining. So 1 electron means there is imbalance between the positive and negative charge. Here the positive charges are 11, the negative charge is 1, because we know proton is having positive charge, electron is having negative charge. Okay, so here the positive charge is exceeding the negative charge, and by how much it is exceeding? By 1. So our sodium atom, after losing an electron, it acquires the charge of +1, because positive charge is exceeding, right? Positive charge is exceeding, and by 1. So sodium atom acquires +1 charge, and when sodium atom acquires +1 charge, we call it as sodium ion. Okay, so now this is sodium ion. So what I will do is, see, I will just erase this 1. Okay, I'm just writing 1 plus. Okay, so I can write here 1 plus also, like this. Okay, Na 1 plus. Okay, or simply Na plus. Okay, if I'm writing Na plus, that also means that I'm showing 1 positive charge. Okay, but for 2 positive charges, you need to write 2 plus. Okay, for suppose example, if some atom is having 2 positive charge, so suppose X atom is having 2 positive charge, so X 2 plus. In this way you need to denote it. Clear how to denote the ion? Okay, fine. So now here, okay, actually you know this thing, but still, since the formation process is new to you, that's why I'm explaining to you this thing. So how our sodium plus ion is formed? How it is formed? By the loss of 1 electron from the sodium atom. Okay, so what I'm going to do is I'm going to just denote this process then here. Okay, see how sodium atom, okay, it lost 1 electron. Okay, it lost 1 electron and it formed sodium ion. Okay, so see, sodium ion having 1 positive charge plus 1 electron. Fine. Okay, okay, or else you can also write in this manner as well. If you want to write this way, see, sodium atom lost 1 electron, formed sodium ion. Okay, so this minus E, if I put it here, it becomes plus E, and what I have written few seconds earlier, that would be the equation then. Okay, chemical equation. So here you can understand this thing. Sodium atom lost 1 electron, formed sodium ion. Okay, now this sodium ion, okay, is having 11 protons, 10 electrons, and how we would denote it, how we would depict it same way. Okay, I'm going to draw the nucleus of sodium, first shell and second shell only. Now the third shell is not there because the electron which was present in the third shell itself, it's lost. Okay, so now since no electron in third shell, no need to show the third shell. Fine. So 2 shells and then 2 electrons in the first shell, 8 electrons in the second shell. So 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Fine. But here we need to show with this bracket here plus sign. Okay, 1 plus or just simply plus, because it is a sodium ion. Fine. Okay, so in this way we have depicted the sodium ion. Okay, so what happened? Sodium atom and chlorine atom, they combined. How they combined? Sodium atom lost 1 electron to the chlorine atom. Fine. Chlorine atom gained that electron. Okay, means sodium atom donated that electron to the chlorine atom. Chlorine atom accepted the electron from the sodium atom. Fine. So there took place a transfer of electron, loss and gain of electron, and then eventually what happened? Sodium atom got converted into sodium ion. Similarly, when chlorine atom, it gains 1 electron, what would happen? Initially it is having, see, chlorine's atomic number is 17. This means that it is having 17 protons and 17 electrons. Okay, when it is neutral, here it is neutral. Okay, no charge on the chlorine atom. Okay, so 17 protons, 17 electrons. But when it accepts 1 more electron, then 17 protons, 18 electrons would be the case. 17 protons, 18 electrons would be the case. Now since 1 negative charge is more, so the net charge would be 1 minus, because 1 negative charge is exceeding, right? So here chlorine, okay, 1 minus. So simply I can just write minus. Okay, how it has formed? When chlorine atom gained an electron. Clear? Simply, it's very simple to write these equations. Okay, just you need to understand this thing. Now we would just simply draw the chloride ions structure the same way we have drawn the chlorine atom structure. You need to pay attention to this thing because the diagram would then become wrong. Okay, so see, so by circles we have denoted the electrons. So here also by circles, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, because the 1 electron of sodium is being accepted by the chlorine, and sodium's electron we have just denoted with cross. So here also you would denote, here it has 1 electron from sodium, right? So you would now denote it with cross. Okay, so this thing you need to just take care of. Clear? So here now it is a chloride ion then. Okay, this chlorine negatively charged ion is called as chloride ion. We all know this thing, right? We have studied in the radicals and ions part in the first chapter itself. So this is chloride ion having 1 minus charge or 1 negative charge. So we need to just denote then the charge, okay, 1 minus or simply minus. Fine, clear till this part. Okay, now this is the sodium ion, this is chloride ion. Sodium ion's electronic configuration is same as that of the neon, 2,8, right, after losing 1 electron. Chloride ion's electronic configuration is same as that of the argon, 2,8,8, after accepting 1 electron. Okay, so this thing is also clear. Okay, or else I would just write it here, 2,8 electronic configuration, 2,8,8. Fine, fine. Now here between this positively charged ion and negatively charged ion, see, there are opposite charges, and we know like charges repel each other. Very simple logic. And unlike charges attract each other. So here sodium ion and the chloride ion, they attract each other. And in this attraction, okay, this attraction results into the formation of, okay, ionic bond between them. And now you can recollect that what is actually an ionic bond? It is the chemical bond formed when there is a transfer of electron from one atom to the another atom. Correct? This only we have studied. So here also see, there is a transfer of electron from one atom to another atom, and when this is taking place, the bond which is formed here, it is an ionic bond. Here between the positively charged ion and negatively charged ion, there is an electrostatic force of attraction, okay, or you can say there is a force of attraction between the positively charged ion and the negative charged ion, which is holding them together, okay, and this force of attraction which is holding these constituents together, okay, in this species is a chemical bond. And which type of chemical bond? Ionic bond, because the bond when it is formed, it involved transfer of electrons from one atom to the another atom, okay. So here our ionic compound is thus formed, okay, because what is ionic compound? It is a chemical compound which is formed when there is a transfer of electrons from one atom to the another atom. Correct? So here this chemical compound is formed in the same way, by the transfer of electron from one atom to the another atom. Clear? So I hope it is now clear to you how sodium chloride is formed. And if someone asks you to draw the atomic orbit structure of NaCl, what you need to do is you need to just simply draw this thing, okay, and just simply write the electronic configurations. Okay, I'm just going to make a box around this so that you could just figure out what you need to do. See, these structures you need to draw, okay, definitely this entire atoms showing the transfer of electron, these ions, charges, and all those things. Whatever I have written there down, out of this, what you need to write is this electronic configuration, this one. Oh, sorry. So how the ion is formed and the electronic configuration, how the ion is formed and electronic configuration. Fine. This thing only you need to write. No need to write all this Rama and Mahabharata and all those things. Fine. Clear? Okay. Now moving ahead, let's see the atomic orbit structure of calcium oxide and its formation. Now the same story would be applicable for this also, because it is also an ionic compound. The same story as that of the NaCl would be applicable. So first of all, now let's quickly go through these compounds, okay, because we already know the basics now. Okay, how the things are going to be formed. So calciums, I'm going to draw the structure of calcium. Okay, so calcium here, nucleus, then first shell, second shell, third shell, and then the final fourth shell. Now why I'm drawing 4 shells? Because I know the electronic configuration of calcium is 2, 8, 8, 2. Fine. So here I will just simply draw the electrons same way as that of the previous one. So how we did in sodium chloride's case, in the same way we are going to do for the calcium. So 2 electrons in the first shell, okay, I am denoting it with circles, then 8 electrons, and then again 8 electrons, and then the 2 electrons. Fine. So this is the calcium atom. Now here we will just draw the oxygen atoms, okay, structure. So same way, exactly the same way, and then we would think ahead what they are going to actually do. Who is going to lose the electron, who is going to accept the electron, fine. So here oxygen atom's nucleus, first shell and second shell, only two shells oxygen would have because its electronic configuration is simply 2,6. Okay, this is the electronic configuration of oxygen. So now here I would just denote the oxygen's electrons by a cross. Okay, so 2 electrons here and then 1 2 3 4 5 6, fine. So here both the atoms would again start the journey of attaining 8 electrons, okay, in its outermost shell. So here calcium would start, okay, calcium would think of attaining 8 electrons in outermost shell. How? By losing these 2 electrons. Okay, it won't gain the 6 electrons. The previous case was of that of the sodium. So in this case also sodium won't think of gaining 7 electrons, okay, because it is not having that tendency to, because it is very much difficult for the sodium to gain that 7 electrons and then make 8 electrons in its outermost shell. Instead it is easy for the sodium to lose that 1 electron. Clear? That's why it would lose the 1 electron. Here calcium would also do the same thing. It's very difficult for calcium to gain 6 electrons. Okay, so instead what it would do is lose 2 electrons and then make its inner shell the outermost shell, so such that it knows that its inner shell already has 8 electrons. So its inner shell then would become outermost shell and it already has 8 electrons. So it's then satisfied. Its outermost shell ultimately became the shell having 8 electrons. So it attained octet in the valence shell. And in turn it also would attain, indirectly it would attain the nearest noble gas configuration, which is of argon. Okay, here the argon is having, here the nearest noble gas configuration is of argon, which is 2,8,8. Okay, argon's atomic number is 18. So after losing this 2 electron, okay, it would form 2,8,8, 2,8,8, and if you would try to write the electron configuration of argon, it is also 2,8,8. So it is attaining the electronic configuration of nearest noble gas, argon. Okay, so I would just write it here, 2,8,8. Calcium lost 2 electrons, fine. So calcium lost 2 electrons, became calcium, and here after losing 2 electrons, what would happen? Here initially it is having, okay, when it is an atom, it is having 20 protons, 20 electrons. But now here after losing 2 electrons, it would have 20 protons still, but 18 electrons, sorry, 18 electrons. So it is short of 2 electrons now. So this means that the net charge is excess of positive charge. And how much it is in excess? 2 excess. Okay, because see, each proton is having 1 plus charge. Okay, so, and each electron is having 1 minus charge. So 20 plus 18 minus. So you can just calculate, plus 20 minus 18, it's plus 2, right? So plus 2 charge is the net charge. Just the same thing we have calculated for NaCl also. The same thing is here also. So plus 2 charge is in excess. So plus 2 charge, okay, or 2 positive charges are shown in this way. 2 positive. Okay, always write as n plus n minus. I have already told you when we were studying in the first chapter, okay, that how to write the charges on the radicals, n plus n minus form. Okay, so Ca 2 plus. Okay, fine, because excess of 2 positive charges are there here. So now in the same case, here when it is losing its 2 electron, which 2 electron it is losing? See this one, see this electron, the outermost shell, 2 electrons it is losing. Now both these electrons, what would happen is oxygen atom would accept these 2 electrons. Okay, when it is losing these 2 electrons, at the same time oxygen atom will pick up those 2 electrons. Okay, and it would gain those 2 electrons. And but why is oxygen doing so? Because see, oxygen is just short of 2 electrons from its nearest noble gas configuration. So oxygen's nearest noble gas configuration is neon. Okay, how? See, oxygen, fluorine, neon. Oxygen atomic number 8, neon atomic number 10. Okay, so oxygen, fluorine, neon, and after neon then comes argon, the next inert gas, which is having atomic number 18. This is having 10. Oxygen's atomic number is 8. So who is near? Neon. And this neon's electronic configuration is 2,8. Now, okay, ultimately it is attaining this nearest noble gas configuration. And how it is doing this? By making its outermost shell having 8 electrons. So here also its outermost shell is having 6 electrons. So for making 8 electrons in its outermost shell, it just is short of 2 electrons, right? So it would gain these 2 electrons. Clear? And these 2 electrons are already given up by the calcium atom. So these 2 electrons readily it would take up, it would make its outermost shell 8 electron, having 8 electron, and once its outermost shell attains 8 electron, it is indirectly attaining the configuration of the nearest noble gas. Okay, and by attaining this configuration, or by making its outermost shell having 8 electrons, it is becoming, the most important thing, it is becoming stable. Every atom here is trying to become stable. The sodium atom, the chlorine atom, the calcium atom, the oxygen atom, everyone is trying to become stable. How? By attaining 8 electrons in its outermost shell. I have already told you this thing. Okay, so same story. So it accepts 2 electrons, then fine, makes its outermost shell having 8 electrons. Okay, becomes stable, also indirectly attains the inert gas configuration, nearest inert gas configuration or nearest noble gas configuration. Clear? So here 2 electrons are accepted. Okay, so after accepting 2 electrons, its configuration is 2,8, right? And initially it is having 8 protons and 8 electrons. But after accepting 2 electrons, what would happen? It would now have 8 protons but 10 electrons. 2 electrons are in excess. So you can just simply write protons charge is +1, so +8, electrons charge is -1, so -10. What would happen is -2, right? Okay, yes, simply. So I'm just erasing this thing. Then -2 is the net charge. So oxygen here would have 2 minus as the net charge. Don't write -2, I have told you n plus n minus. Okay, so n is here the number, so 2 plus or 2 minus you can write. Sorry, here it is -2, right? So you can write as 2 minus because the format is n plus n minus. Simple. So how it became 2 minus? By accepting 2 electrons. Clear? So oxygen accepted 2 electrons and 2 minus, right? Here oxygen accepted 2 electrons, and because of that 8 protons and 10 electrons now are present. And here after this, since 8 protons and 10 electrons are there, 2 negative charge is in excess, therefore the atom is acquiring 2 negative charge, and when it acquires this 2 negative charge, it becomes an ion. Okay, and here it is an negatively charged ion, therefore it is an anion. Very simple. Also it is having 2 negative charge. Okay, here it is having positive charge, calcium, so it is a cation. Fine. Clear? So negatively charged ions are called anion, positively charged ions are called cations. Very simple. And here 2 positive charges, 2 negative charges. Okay, this is called as calcium ion, this is called as oxide ion. Okay, we already know this thing, we have already studied in the first chapter itself. Okay, radicals 1. So here it is forming an oxide ion. Now let's draw the structures of calcium and oxygen, so calcium ion and oxygen ion, right? Or calcium ion and oxide ion. Okay, so what would be the, how we can draw the structure? Now we know here the electronic configuration is given 2,8,8. We have already written here it is 2,8. So 3 shells need to be drawn. So calcium, okay, 1, 2, 3. Fine. In each shell we need to fill the electrons. So 2 electrons in the first one. Now so let's see the with which we have denoted the electrons of calcium, circles. So 2, 1, 2, 3, 4, 5, 6, 7, 8. And then again 8, 3, 4, 5, 6, 7, 8. Fine. But in the process it gained 2 positive charges. So bracket 2 plus. Fine. In the same manner, oxide ion. Okay. So 2,8 only this thing. So here oxide 1, 2. Okay. 2 shells. First shell 2 electrons. Second shell 8 electrons. So first shell 2 electrons, second shell 1, 2, 3, 4, 5, 6, and be careful because these 6 are of its own, but the remaining 2 are being gained from calcium. So calcium's electrons are denoted by circles. So we need to draw here circles. Okay, no need to take care of the colors and all those things. I am just making it colorful so that you could clearly see where are the electrons and in which shell they are. Okay, so here 2 electrons from the calcium, therefore 2 circles here. So 8 electrons in total, right? Clear? But in turn it gained 2 negative charges. It became an oxide ion. So it gained 2 negative charges. Fine. Okay. Now between this positively charged calcium ion, negatively charged oxide ion, again the positively charged and negatively charged ion would have a attractive force between them. Okay, and here this is called as electrostatic force of attraction. Fine. And here this electrostatic force of attraction is there between them, and we know now this bond is formed because there is a force of attraction here between these constituents which is holding them together in this chemical species. So this is a chemical bond, right? The definition of chemical bond, I have just repeated it. And then this chemical bond is formed by the transfer of electrons. So ionic bond, very simple. So ionic bond has been formed here, and since this compound is formed by the transfer of electrons from one atom to another, so such compounds are called as ionic compounds. So this is an ionic compound, calcium oxide. So the initial compound which we studied was NaCl. So what would be the formula? Simply the atoms which are combining, just write those atoms symbol in front of each other. So it was sodium ion and chloride ion. Okay, so simply write NaCl. Right, one sodium ion, one chloride ion, so NaCl, right? Then here one calcium ion, one oxygen ion, right? So CaO. This would be the formula. Clear? Understood? Okay, now again the last compound, the last ionic compound whose formation we have to study and whose atomic orbit structure we have to draw, okay, and learn how to draw. So this is magnesium chloride. So starting from the elements, okay, so here we are just dealing with one magnesium atom and two chlorine atoms, because see here there are two chlorine atoms in this compound. Okay, so now we need to be extra careful while drawing the structure because we need to just adjust some space as well. Okay, so here this is magnesium Mg nucleus. Now magnesium's electronic configuration is 2, 8, 2, since its atomic number is 12. Okay, so you can get to this point, you get the electronic configuration by on your own. It's very easy. Okay, so 3 shells, first, second, third, and then the electrons simply 2 here, 8 here, and then 2 here. Now drawing the chlorine atoms. Okay, so now it's very easy. You can just pause it here itself and you can draw it on your own because we have already studied drawing the structure of chlorine atom, right? Right, very simple. So here this is chlorine, first shell, second shell, third shell, and then again here chlorine, first, second, and third. And here for chlorine atoms, we know for both of them the electronic configuration, both of them are chlorine atoms. So 2, 8, 7, 2, 8, 7. Perfect. Okay, showing the electrons is also a very easy job. So what you simply need to do is, you just need to, I will draw just the circles. Okay, so 2 circles here, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Okay, so I have just drawn it in reverse order. Now till this point it's very clear, it's very easy, just drawing the structure of the atoms. But now what would happen is the story here, which is very interesting and which would help us to know how magnesium chloride is formed. So again the same logic, same thing, both the atoms, okay, means all the 3 atoms here, they want to become stable, they want to attain 8 electrons, they want 8 electrons in their outermost shell. So magnesium can gain or attain that 8 electrons, or can make 8 electrons in its outermost shell. How? By just losing these 2 electrons, by getting rid of these 2 electrons. Chlorine in turn, each atom needs just 1 electron so that it could make its outermost shell, as the shell which is having complete octet or 8 electrons. Here also same thing. Okay, here instead of gaining 6 electrons, magnesium thinks that I won't gain 6 electrons, I will instead give these 2 electrons and make my inner shell as the outermost shell, because my inner shell is already having 8 electrons. So it would ultimately become my outermost shell having 8 electrons. Clear? Okay, like this, ultimately become my outermost shell having 8 electrons after losing these 2 electrons. Clear? So it loses the 2 electrons. Again the same logic would be carried forward. Its electronic configuration will become 2, 8. Okay, after losing the 2 electron, what would happen is, here initially there are 12 protons, 12 electrons, but now after losing 2 electrons, okay, what would happen? Okay, here there would be 12 protons and 10 electrons. So if you would calculate, okay, plus 12 minus 10, okay, simply it's plus 2. So 2 positive charges are net charge is 2 positive charges, because 2 positive charges are exceeding here in this case because of short of 2 electrons. So 2 positive charges are exceeding, therefore the atom would attain or gain 2 positive charges, and once it gains 2 positive charges, it becomes an ion. Okay, so this is an magnesium ion having 2 positive charges. Fine. So our magnesium losing 2 electrons, it would form magnesium ion. Clear? And same way here, now these 2 electrons which are lost by the magnesium, each chlorine atom requires 1 electron each. So suppose these are the 2 electrons now, right? This one and this one. So this one would be accepted by this chlorine atom, this one would be accepted by this chlorine atom, because both of them, okay, actually each one of them needs one only. So here 2 are being lost, one would be taken by this atom, one would be taken by this atom. Both of them, once accepting this 1 electron each, they would become 2,8,8, 2,8,8. And the same thing, okay, when the chlorine atom accepts 1 electron, okay, we have already seen, right, chlorine atom accepting 1 electron, okay, becomes chloride ion. Fine. And it is having this net negative charge, 1 minus negative charge, okay, and its electronic configuration becomes 2,8,8. Okay, so I'm not going to repeat that same thing. So you all know, okay, what would happen here? It's simply 2,8,8 then, okay, 2,8,7 would become 2,8,8 because outermost shell is getting 1 electron. Fine, fine, in both the cases, for both the chlorine atoms. Okay, now here we are talking about 2 chlorine atoms, right? So this 2 chlorine atoms, I would just write it here as 2 chlorine atoms, okay, gaining 1 electron each. So I would just simply write 2 electrons then, okay, cumulatively, okay, sum total, 2 chlorine atoms gaining 2 electrons, okay, forming 2 chloride ions. Okay, so if you feel difficulty in this thing, what we can do is we can just simplify it. We know here 1 chlorine atom is gaining 1 electron. After gaining 1 electron, it is forming chloride ion. Okay, why? Because after gaining an electron, the electrons are becoming in excess, and how much electron is in excess? 1 electron is in excess. Therefore, the net charge acquired by the atom is 1 minus. Okay, the same that of the sodium chloride's case. Okay, we have already seen how I have just now shown you. Okay, the chloride ion, how it is formed, because now there would be 17 protons and 18 electrons. Right, so 1 electron is in excess, so 1 negative charge in excess, so 1 minus. Clear? Same with this also, this chlorine atom also, exactly the same case, accepting 1 electron and becoming a chloride ion, right? Because 17 protons, 18 electrons, 1 electron excess, 1 negative charge excess. Now, okay, so 1 negative charge excess, so now it became chloride ion. So see, 2 chlorine atoms, 2 electrons, right, and then 2 chloride ions. Correct? So what I have written, it simplify, means I have just simplified these 2 equations and just have written here. Clear? Fine. So now let's simply draw the structures then. So here magnesium 2 plus ion. So here see, all these 3 are combining, okay, and what is going to happen is, see, magnesium 2 plus electron configuration 2,8. So here 2 electrons, here 8 electrons. Okay, I'm just showing here in this way, crosses now. 2,8, 3, 4, 5, 6, 7, 8. Clear? And then 2 positive charges, right? 2,8 configuration. So I have drawn the structure, I have distributed the electrons according to the electronic configuration, and then what it is getting converted into after losing the 2 electrons? Magnesium 2 plus ion. Correct? So Mg 2 plus ion. So this means 2 plus charge is there, right? So I need to show this 2 plus charge here. Correct? And then in case of chloride ions, there are 2 chloride ions getting formed, okay, by respectively gaining 1 electron each. So I'm just going to draw 2 chloride ions here. So see here, this chlorine 1, 2, 3, this chlorine 1, 2 and 3. Fine. And here, while distributing the electrons, now here electrons are in circles, right? Circles. So 1, 2, 1 2 3 4 5 6 7 8, and then here 1 2 3 4 5 6 7, one electron from the magnesium, so I would just write here cross. Same case with this also, 1 2 3 4 5 6 7, one electron from magnesium, right, cross, and then remaining same 3 4 5 6 7 8 1 2. Okay, now both of them are now, see, 2 comma 8 comma 8, we have just drawn the structure according to the configuration, keeping one thing in the mind, that the electron which is accepted to make the outermost shell 8 electrons, having 8 electrons, is from the magnesium. So denoting the electron symbol of magnesium here. Okay, this thing we have taken care of, only this thing, that's it. Okay, now here it is chloride ion, so one negative charge is there, clear, with each chloride ion there is having one negative charge, so see, one minus, or just simply minus you can write, okay, minus, and here also minus. Okay, now between this positively charged magnesium ion and two negatively charged chloride ions, there is a, see, positively charged ion, negatively charged ion, so there is a force of attraction between them, and this force of attraction, okay, here is binding them together, holding the constituents, okay, holding the ions together in this species. So this is resulting into the formation of chemical bond. And how is this forming? By transfer of electrons, right, by transfer of electrons. So when a chemical bond is formed by the transfer of electrons from one atom to another, it is an ionic bond. So here ionic bond is formed, and since the compound is being formed by the transfer of electrons from one atom to another atom, we know this is an ionic compound. So now here we have just formed ionic compound MgCl2. Now simply how to write the formula? 1 Mg atom, 2 chlorine atoms. So simply 1 Mg atom, 2 chlorine atoms. So formula is MgCl2. Clear? Okay. How to draw the atomic orbit structures for all the three ionic compounds I have explained you, okay, in depth, as well as what all things to write as well. Okay, so these structures along with the electronic configurations, okay, electronic configurations which I have already written here, okay, here also, and also the equation. Okay, so you can write both, you can write either this or this, anything would do. Okay, just it's to help you understand how what is actually getting formed. Clear? Okay, my friends, then now let's move on to the question section. Okay, let's see how much you have understood. Okay, so very simple questions, no need to worry. So first is, an atom X has 3 electrons more than the noble gas configuration. 3 electrons more than the noble gas. Okay, what type of ion will it form? Okay, so we have just now seen the two examples, one of sodium atom, one of calcium atom, and also one more example of magnesium atom. Now in case of sodium atom, it was having 1 electron more than that of the noble gas configuration. Okay, see, 1 electron more than the noble gas configuration. Here in case of calcium, 2 electron more than the noble gas configuration. In case of magnesium also 2 electron more than the noble gas configuration. Okay, so what I have already told you that, okay, whenever we have already studied this, when we have studied the valency in the chapter number 1 itself, whenever the electrons, okay, in the outermost shell are 1, 2 or 3, okay, so what the atoms do is they have the tendency to lose the electrons, okay, and make their inner shell as the outermost shell having 8 electrons. Clear? So suppose if an atom is having 3 electrons more than the noble gas configuration, suppose it is having 3 electrons, okay, more than the noble gas. Now suppose I am taking for example, okay, aluminium, okay, for example aluminium. Now aluminium, here it is having electronic configuration 13, atomic number 13. Its electronic configuration is 2, 8, 3, in order to make you understand. Okay, so here it is having, now when I would see neon's electronic configuration, okay, atomic number 10, its electronic configuration is 2, 8. So this aluminum is having 3 electrons, see, 3 electrons more than the noble gas configuration, So this is the noble gas configuration, 2, 8, 2, 8, but 3 electrons more than the noble gas configuration. So what it would do, I have told you, okay, whenever the outermost shell is having 1, 2 or 3 electrons, I have told you, we have already studied this thing, it would lose the electron. It has a tendency to lose the electron, okay, and make its inner shell, okay, as the outermost shell having 8 electrons. Clear? So it would lose the 3 electrons. Once it loses 3 electrons, if aluminium loses the 3 electrons, what would happen? Okay, here initially it is having 13 protons, 13 electrons, correct? But after losing 3 electrons, now it would have 10 electrons. Now if I would just calculate, protons charge is +1, electron -1, so plus 13 minus 10, okay, plus 13 minus 10 is +3, so net charge is now 3 positive charges. So here our aluminium atom would attain 3 positive charges, okay, 3 plus, okay. Now this would form 3 plus ion. So now this example in which I have taken aluminium, okay, they are just asking atom X has 3 electrons. So now in place of aluminium, if I would just erase and I would write atom X here, okay, it will satisfy because it is also having 3 electrons more than the noble gas configuration, correct? So instead of writing here Al3 plus in the answer, I would just write X3 plus, just simply substituting aluminium with X. Okay, so for understanding purpose, I have taken the example of aluminium, but what they want in our answer is in terms of X. Okay, so ion of X would be X3 plus. Okay, so atom X has 3 electrons more than noble gas configuration. What type of ion will it form? X3 plus ion. Clear? Okay. Okay, now in continuation with this, what they are saying is write the formula of its, okay, this X3 minus ions, sulfate, nitrate, phosphate, carbonate, hydroxide. Okay, so now we all know it's just simply we have to just take this X3, okay, this is a radical for us now, okay, and then sulfate, SO4 2 minus, right, nitrate, NO3 minus, phosphate, PO4 3 minus, right, sulfate, nitrate, phosphate, carbonate, CO3 2 minus, and hydroxide is OH minus. Now just we need to just use the crisscross method and write the formula. So like now crisscross method we are like studying it, we have studied it in first chapter itself, okay, and it's very simple. So we can just, without writing itself, we can just use the crisscross method by our eyes only, okay, without using the pen. Okay, so now see, 3 would go here, 2 would come here, so X2 SO4 thrice, fine, X2 SO4 thrice, correct. Here again the same, you have to just use this, okay, same X3 minus, X3 minus, X3 minus, X3 minus, same radical is there. So here again this would go to nitrate, this would come to X, right, the crisscross one. So here X NO3 thrice, right, X NO3 thrice. Okay, if it's quite tricky, then what we can do is we can simply write everywhere the X3 plus, so that it would be easy again, more easy by using the crisscross method then. Okay, so see again X NO3 thrice, fine, then X3 PO4 thrice, okay, see X3 and then PO4 thrice, so X3 PO4 thrice, and here again see X2 CO3 thrice, okay, so X2, okay, X2 and then CO3 thrice, CO3 thrice, and then here, okay, XOH thrice, fine, so XOH thrice. So this would be the formulas. Okay, this part is quite easy, but this was a little bit tricky one, fine. Okay, now moving ahead to the next one. Now in the formation of compound XY2, an atom X gives 1 electron to each Y atom. Okay, in formation of XY2, okay, what they're saying, an atom X gives 1 electron, okay, gives 1 electron, fine, to each Y, fine. What is the nature of the bond in XY2? So see here, atom X is giving 1 electron to each Y atom. So here there is a loss of electron by X, gain of electron by Y atoms. Okay, so there is a transfer of electrons. from one atom to the another atom, and then the compound is being formed. In the formation of compound, they have said, right? So whenever there is a formation of compound which involves transfer of the electrons, okay, so here it is an ionic compound, and when such compound forms, okay, so we know also the chemical bond, okay, when it is formed by the transfer of electrons from one atom to another atom, it is ionic bond. Okay, so what would be the nature of bond in xy2 then? Okay, ionic bond, since here the transfer of electron is taking place from one atom to another atom, so bond which would form here, okay, would be ionic bond. Okay, because simply ionic bond is the chemical bond which is formed when there is a transfer of electrons from one atom to the another atom. Clear? So here ionic bond, okay, very simple, right? Very easy. Electron is being given by X to each Y atom, okay, and we know in ionic bond, okay, it is actually a chemical bond when the transfer of electron takes place from one atom to the another atom, right? Ionic bond. Next is draw the atomic orbit structure of this compound. So can you just correlate this thing with the magnesium chloride, right? We know magnesium atom, okay, it also in the similar way has given each electron, one electron each to the chlorine atom, correct? See here, just now we have seen some minutes ago, okay, magnesium one electron to each chlorine atom, so this is X electron giving to Y atoms, the same scenario, exactly the same scenario, X electron giving to the Y atom, X electron giving to the Y atoms. So what they are asking, draw the atomic orbit structure of this compound. So simply what you have to do is you need to draw the atomic orbit structure same as that of the magnesium chloride, but instead of this magnesium chloride, the compound's name is XY2. So substituting everywhere in the orbit structure of magnesium as X and everywhere in the orbit structure of magnesium chloride, okay, substituting this chlorine by Y will do our job. Okay, so exactly what I need to say is the atomic orbit structure of magnesium chloride, okay, would be exactly the same as that of the atomic orbit structure of XY2, and already we have seen the atomic orbit structure how to draw for magnesium chloride. So I hope you can simply draw the atomic orbit structure for XY2 as well. Okay, done. So friends, with this we have reached the end of this video, and I hope you would have enjoyed learning with me. You would have understood all the concepts. Okay, but please do let me know this thing in the comment section. And as you all know, learno matlab free है पर best है. So see you in the next video with the remaining concept of this chapter, which is covalent bonding. Till then, keep studying, stay safe, and have a great day.